All right, this is homework 8 for Maple. I'm going to go through the problems. So yes, we start with problem 1, which is just to find some derivatives and integrals. So we start with the following function. F of x is a polynomial, 2 times x to the 5th minus 107 times x. Oops. State that out. Everyone makes. Put the cursor down. 2 times x to the 5th minus 107 times sine x. That's fine. So the derivative of f at x is the derivative. And the indefinite integral, I use capital I, x, it just gives me the statement of the problem. To lowercase I get the answer. That's the indefinite integral plus a constant. Let's see. I don't need to do them all, just do a couple. So suppose f is this trigonometric function. X goes to, well, I'll do them all. 2 times x to the 5th minus 107 times x plus 5. I put parentheses around this so that when I divide, that whole thing becomes the numerator, x cubed plus x plus 7. So again, the derivative of f evaluated at x is this complicated thing. I know you have a Maple to simplify it, this is C. It puts it over a common denominator. Makes it simpler. To integrate, I could use exactly the same command that I have a new function f. What this says is this is really complicated. This is not wrong. It means that some integrals can't be done and this can't be done. That's Maple tells you exactly what it is. The trigonometric function is f of x is the tangent of x plus the secant. And the derivative of the tangent is secant squared, and the derivative of the secant is secant times the tangent. You might say, well, why don't I see secant squared here? Because Maple just chooses to use it for that identity, which is that 1 plus tangent squared is equal to secant squared. In part D, f of x is 1 over 49, oh, sorry, 4 plus 49 times x squared. So the derivative of this is a rational function, and the integral interesting. So it's the arc tangent. You won't know that probably in Math 175, but you definitely will learn it in Math 175. Problem 2. Problem 2, we want some definite integrals. So let's see. In this case, I'm integrating is the function x cubed. And when I want a definite integral, I have to give the upper and lower bounds of integration. X goes from -1 to 1. 2. Let's go from -1 to 1. Wow, so it turns out that answer is 0. It's an interesting exercise to understand why that is. You want the integral of the log of, let's see, how did you absolute value of x? I believe you could say ADS of x for absolute value. Let me just try that. The integral of the absolute value of x from -5 to -2. That's exactly what it is. But I use a capital I, so I just get the statement of the problem. I don't get the answer, so I have to use a lowercase. Now for that, equals. Change the uppercase to a lowercase. That's what it is. And problem 4, problem 2c is the integral of this function. From 0 to pi over 14. And we have to do capital P for pi. That means 3.14 pi over 14. Yeah, that looks right. So this is equal to the same thing, but with a lowercase I. That's what we do. Tangent. Oh, that's 4 over 14. That's problem 2. Let's go to problem 3. So we have a function log of x squared. So if you want to plot it, plot log of x squared plot, plot log of x squared from x equal to 0 to 2. Yeah, that's what it looks like. The area under the curve is the definite integral. It might be a little bit complicated. Let's see. And if the integral of log of x squared, x going from 0 to 2. That looks right. See if Maple can calculate the integral. Yeah. This is what it is. If you want it as a decimal for whatever reason, it's interesting to see what that is. So this will convert to a decimal. So the area under this curve from 0 to 2 is 2.1891. Okay. Problem 4. So we want to plot okay, sorry. This is to continue the homework 8 from Math 155. So I was up to problem 4, and we are going to, first of all, plot the function sine x, x going from 0 to 2 pi, 2 times capital Pi. And that's the plot. You want to see it to scale, right click or scaling constraint. That's what it looks like. To find the area under the curve from 0 to pi, integral sine of x, x equals 0 dot dot pi, equals, and now write the same thing with the lowercase I. So that's the area from 0 to pi. It's positive 2 because the curve is above the x-axis. If we look at the integral from pi to 2 pi, that's the integral over here. Now, this curve is below the x-axis. So this integral should be negative. Geometrically, they're very similar, but an integral gives you an area with a plus or minus sign. It's the area above the axis, x-axis, minus the area below. And that's why if we were to integrate from 0 to 2 pi, you should get 0. Because it's not that the integral from 0 to pi is twice the area of half of that region, the integral from 0 to pi. Positive area, negative area, they cancel out, and that's why we get a 0. Okay. Let's look at problem 5. We have a certain ellipse that we would like to graph. And for that, the easiest thing is to use implicit diff. So let's open the plots package with plots. So the one we're going to use, sorry, implicit plot. That's one that's here. If I can end this with a colon, I don't think of that writing on the machine. So implicit plot, if the curve is given implicitly by this equation, the equation is x squared over 24 plus y squared over 54 equals 1. And we need to give a range of values for x. Say x goes from -5 to 5. And y, let's say, goes from -8 to 8. Let's see if we get a nice curve. Oh, there it is. It looks like a circle, not an ellipse, but that's because the units horizontally are different than the units vertically. So if we graph this to scale, that's really what the ellipse looks like. And we want to find the area. So one way to do that is to solve this equation for y. Let's see what happens. Let's say, suppose you try to solve this equation. For y. So we get two functions, this and this, plus sign, minus sign. So this is the equation of the top half of the curve. This is the equation of the bottom. So if I want the area, I can simply say, well, if I just want to calculate the area of the top half, the area of the bottom half is the same. Just multiplied by 2. So this will be 2 times the integral of this function from here to here. What is this point? Where does this ellipse intersect the x-axis? Well, it intercepts the x-axis when y is 0. You want to know when y is 0, what is the value of x? So let's see, maybe I will insert that here. So if I want to solve this equation for x, so I want to know what is this when x is equal to, when y is equal to 0. So I want to find parentheses. It's going to be the square root of 24 plus or minus the square root of 24, which is 2 root 6. So I'm going to integrate this. X goes from minus 2 root 6 plus root 6. And that is the answer. 36 pi. Very nice. Well, that's how we do all the problems. Stop the recording.